Hello everyone, my name is Noah Moorhead and my presentation is on the chemistry of wildfires in Ventura County. I'll be explaining how wildfires burn from a chemical perspective, including what fuels them, what gases and particles they produce, and how these processes affect the environment and also the people living here in Ventura County. Ventura County is one of the most wildfire-prone areas in California because of its dry Mediterranean climate and below average rainfall levels. About 77% of buildings in the county are considered at wildfire risk. One major example is the 2017 Thomas Fire, which burned nearly 282,000 acres and destroyed over 1,000 structures in the city. Events like that show how closely chemistry and environmental conditions shape the hazards our community faces. So, every single fire relies on three big components: fuel, heat, and oxygen. Together, they form what is called the fire triangle. If one of these is removed, combustion stops. Wildfires need at least about 16% oxygen to stay burning, and understanding this balance helps us see how quickly fires can spread in the dry, windy conditions like those can be in Ventura. The main fuels for wildfires are plant materials made out of natural polymers, which are large chain-like molecules. The three major ones included are cellulose, hemicellulose, and lignin. These polymers store energy in their chemical bonds. When they ignite, they break down and release that energy as heat and light. In Ventura's oak woodlands and chaparral, these compounds determine how fast vegetation burns and what kind of smoke is produced from the fire. When these wildfires occur, the type of chemical reaction is a combustion reaction. Combustion is the chemical reaction between these fuels and oxygen. In complete combustion, you mainly get carbon dioxide and water vapor, but when oxygen is limited, you also get carbon monoxide, soot, and methane. For example, the pine resin, which is common in local vegetation here in Ventura, burns to form carbon dioxide and water. These reactions explain why wildfire smoke is full of both visible particles and invisible gases. Next up, we have the products of wildfires. As you can see in this image, we have the reactants, which cause the fire, with the fire triangle in the center, and then the products coming out of the fire. The main chemical products of wildfires include carbon dioxide, carbon monoxide, methane, nitrogen oxides, and soot. These gases contribute to greenhouse effects and air pollution, while soot and fine particles absorb heat and darken the atmosphere. Together, they affect both local air quality and global climate, making wildfire chemistry a major environmental issue. One of the most concerning pollutants is particulate matter, or PM for short. PM10 refers to dust and ash, while PM2.5 includes the tiny smoke and soot particles that can travel deep into the lungs. During the Thomas Fire, the PM2.5 levels in Ventura were over 10 times higher than the safe limit. These particles cause coughing, asthma, and long-term respiratory issues, especially for children and older adults. Next up, we have the environmental impacts. Beyond just health effects, wildfire chemistry also influences ecosystems. Gases such as carbon dioxide and methane trap heat in the atmosphere, which drives climate change. Ash and soot can settle on soil and water, changing pH and nutrient levels here in our local watersheds. Even after a fire is out, the chemical residues left behind continue to affect our plants, wildlife, and our coastal waterways for months on end. Wildfires burn in several chemical stages. It starts off with preheating, when heat from nearby flames drives off moisture and volatile gases in the vegetation. Then comes flaming combustion, where these gases mix with oxygen and ignite, producing visible flames and releasing the most heat and light. After that, the fire enters the smoldering stage, where lower temperatures and less oxygen cause incomplete combustion, producing more smoke, carbon monoxide, and fine particulate matter. Understanding these stages helps firefighters predict fire behavior and smoke production in places such as Ventura County. In summary, the chemistry of wildfires comes down to three parts: the fuels, the reactions, and the products. By understanding what burns and how combustion happens, we can better predict pollution and plan prevention strategies. For Ventura County, this knowledge helps shape smarter fire management, community preparedness, and cleaner air for the future. Thank you.